Good evening, everyone, and welcome to the webinar Semantic Bill for the GPT Chat Hangover, a webinar in the Big Data Demystified series. I'm Anat Stein, and I will speak today with Ina Tukarev-Sela about ChatGPT and generative semantic fabric. Ina is the founder and CEO of Illumex, a platform for generative AI for automated data and analytics interpretation. Throughout her career leading data products and as a data stakeholder, she recognized the oxymoron of our domain. Despite huge investments in data and analytics, most business decisions are still not based on data or on insights. Therefore, she brings her vast industry and academic experience to solve this conundrum and help data and business teams scale trust-based decision-making. Before embarking on her entrepreneurial journey with Illumex, Ina was VP of AI at Sisense and Senior Director of Machine Learning at SAP. She led the product and GTM for cloud and machine learning, built AI-driven platforms within the organizations, and established data science departments. She authored several patents on knowledge graphs, natural language, and deep learning, and she is a frequent speaker at leading data and analytics and AI conferences. Ina is a graduate of Stanford MBA Executive Program and holds an MSc in Information Systems with Neural Nets and a BSc in Physics and Computer Science from Tel Aviv University. She has 20 years of experience with graphs and with data and analytics. Ina, how are you today?
Hi, Nat. Thanks. It was just like hearing my mother telling my CV. So I appreciate that. Great to see you all. And it's August. It's evening for vast majority of participants. So really appreciate that you taking your time and attending the session. And just for the logistics, feel free to ask questions during any part of this conversation, and by both raising the hand and posting in the chat. If anyone has questions, even before we start talking, feel free. Okay.
Great. So the title of our session is Semantic Bill for the ChatGPT Hangover. What is that exactly? What are we going to talk about today?
So today we are going to cover the most buzzed combination in data analytics world, right? So generative AI and specifically ChatGPT takes our industry by storm, and we have quite a hangover, especially within data practitioners, of considering the consequences of implementation such practices and giving vast majority of business users access to such technology. I heard about many POCs already held across different industries using generative AI and specifically ChatGPT on enterprise data, and lots of challenges by using those technologies. And today we are going to talk about, first of all, what is generative AI and ChatGPT implications for data analytics practice, and how semantics or semantic AI, semantic layer connected to this data stack, which could facilitate better implementation and less challenging environment for less technical consumers within enterprise.
So to pick up on that, could you elaborate a bit about both topics that you've just mentioned, the ChatGPT in the business world and semantic layer as a solution?
Yes, so let's speak about generative AI. Okay, so generative AI, as you already know, is a huge opportunity. So McKinsey estimated the footprint of potential value as just above $4 trillion USD on the annual basis. So it's over GDP of countries like England, for example, a huge amount of money. And when we speak about the difference between AI and generative AI for value creation, it's about 40% estimated difference. So this is why we see inflated valuations of generative AI startups, but also increasing investments in how organizations plan the future with generative AI as potential revenue driver. So this is where we see generative AI coming to enterprise in vast majority of use cases. From, for example, a go-to-market function, think about sales, marketing, customer success, and so on and so forth, mostly focused on text generation, right? And up to traditional industries such as supply chain, pharmaceuticals, and so on and so forth. So the opportunity is endless, but we also have some pitfalls in implementations. Going to share it later. And what semantic AI is. Okay, so semantic AI is also a new kid in the block, right? So it's a buzzword which was born recently. Semantic layers existed for a little bit longer. And what we see right now is a reincarnation of huge amount of interest of semantic AI in the context of generative AI implementation in enterprises. Why? Because semantic layers, semantic AI is basically the idea to understand both sides of the table, understand the business language, understand data language, and connect both of them in impromptu scenario with some automation. So it's kind of think about Babel fish, right? It sits in your ear, translates business logic into data elements, and translates what's hidden in data as insights to business users. So this is exactly what semantic AI is.
Thank you for setting the ground for the discussion. Let's explore for a minute the challenges of large language models used within organizations. AI in general, and more specifically generative AI, made leveraging corporate data easier. However, this practice also raises data privacy and security concerns. What are the barriers for LLMs adoption in corporate today?
So I wouldn't quote industry analysts. Let's go to practitioners. So recently, a very famous conference, which is called DGIQ, Data Quality and Governance, took place in San Diego, and they had a poll across all participants. And you can imagine that people who go to such conferences are pretty advanced practitioners and thought leaders in the world of data quality and governance. And when this poll was run, they asked questions like where the risks are coming from. So about 35% of the audience actually stated that their company has banned use of third-party generative AI services for any type of usage. And 25% of the participants stated that they're just creating the strategy or policies about how generative AI is used. And where those challenges are lying, I would say it would be the 3 types of buckets. So first of all, basically security, right? So if it's a malicious software, which is run as a prompt, like so simulating user and trying to penetrate the systems with different access types, so not always third party, and even internal generative AI has access right implemented as part of the flow. So those malicious software can exploit those holes in the flow. Starters. Second one is you can ask prompts in different ways. So even if you do not have access to data, you can ask derivative questions and get access to derivative calculations. So it goes beyond access rights. So all of those, of course, biases. General purpose large language models are trained on internet data like Wikipedia and Twitter, and thus even if your internal data is free from biases, the model brings inherent bias within. So this is another risk. And the third one is leakage. So basically exposing your proprietary enterprise data to training of third-party tool. We'll talk later how you can confront or how you can address all of those, but those are major risks which you're exposed.
Okay, some pretty big challenges. And semantic layer, how does it help to tackle those challenges?
How we can tackle those challenges. So first of all, we should implement a workflow which is enterprise ready. If you're asking question about internal enterprise data or combination of internal and external data, you can think about workflow which is comprised out of 4 components. First of all, you have your input component, right? The way you interact with the system. Prompt engineering, per se, the input. Second part is the model itself. So it's a black box, which you cannot really reverse engineer, right? So if you're speaking about Azure hosted OpenAI or Bedrock hosted on AWS or other models, even those that you download and implement in internal data pipelines like Llama 2 as well. And all of those, of course, you cannot reverse engineer. The third component is validating the output. So basically, three major components of the workflow. All 3 of them have to have controls on top of them. So if we speak about biases, leakages, training on your data, and so on and so forth, those are DPA policies of providers. So go through overchanging policies. You should notice that when you sign such a policy to use a service, policies change. So for example, before May 12th, the policy of OpenAI service didn't really state that you can govern and control your data for training environments. Since May 12th, you can actually mark that you are not interested in sharing your data for training. And again, it's not it's not written in heaven. It could change any moment, so you should keep tabs open. For example, Bard, hosted by Google, of course, is only limited to the training in the context of your own workspace if you're commercial clients. So for commercial use, you're guarded. Again, policies change from time to time. As for validation, and we speak about validating the answer. So for example, like in Hitchhiker's The Guide to Galaxy, you got the answer 42. How do you check it? How do you validate it? I understand the answer is actually correct. So validating answers does require some intimacy. I do not expect every answer to every question to be validated. I think it's overhead. It actually will diminish the whole idea, ask anything. Right, so this is where we are. We cannot do much. Where we can do a lot, and here I'm coming also to the question posted on chat by David, is basically bringing a semantic understanding of your organizational data and being assistants to the prompt engineers, understanding what they asked, interpreting the question, mapping them to the right data elements, and also understanding if the user can actually access the specific, I don't know, data tables, schemas, dashboards, and so on and so forth. And then when understanding, interpreting those questions, also sending third-party tools like ChatGPT context, which is focused on specific parts of what's been asked. And maybe I will just take the question on the chat. So it's a question about LMX. we can talk about LMX in the last part of the system, but yeah, the idea is to basically connect to metadata from applications and data sources, generate semantic layers, which is comprised of ontologies, taxonomies, and semantic logic, such as business terms, metrics, and so on and so forth, and expose it via APIs and applications. So this is exactly what we do, and also provide API support of prompt engineering. Okay, perfect.
So you mentioned semantic layer, and we talked about it as a solution to the challenges. Can you explain a bit about it more? What are the technologies behind semantic layer, for example?
Yes, so semantic layers is among the most misused terms in data analytics world. So they're used as synonyms with metric stores, with feature stores, with with many other components. Some say that semantic layers are basically aggregated layer implemented within either data source, think about the warehouse, for example, or in the BI tool, or in some cases even within ETL, right? So we already heard about the acquisition which happened last year. Transform was purchased by DBT. In all of those cases, semantic layer terminology was misused, to me, at least. My opinion is that semantic layer should be Switzerland. It should sit just in between data sources such as data lakes, lakehouses, warehouses, databases, files, what have you, and the applications. Applications could also include chatbots operated by people, right? And the semantic layer is a translator which understands business question, translated to data objects, and vice versa. Technology which empowers semantic layer, which was recently actually named as Semantic AI by Gartner just a couple of weeks ago. So we have a new term which is called Semantic AI. And this is a combination of graph technologies to provide the relational model, right, to connect different entities to each other, and relational model to connect entities to each other, and semantic model which could be represented by large language models. So combination of NLP, especially of the latest reincarnation of large language models, and graphs, and the latest reincarnation of graphs, of course, graph neural nets. The combination of semantics and relations gives us the ultimate semantic layer. And how we can, or which data we should use to create semantic layer, right? So the most straightforward approach to use metadata. And I'm saying metadata because it has a semantic component, names of different elements, aliases, BI metrics and dashboards. So lots of semantic meaning could be derived from metadata of data sources and application. And the second one is basically graphs. So graphs can understand the usage context, right? So we already use data for specific use cases, but as humans, we tend to not being aligned with our counterparts and our peers to how we use different components. The power of a semantic layer, which combines silos within an organization, is to be able to name different logic entities in a very well-defined way. So, for example, how we define lost loan, how we define the VIP customer, how we define NRR. So both business terms and metrics on top of them. Was it a question online? No. Okay.
You mentioned graphs, and I saw that you had a very, very extensive experience with them. Would you like to elaborate a bit about their history and how they came to be used in this huge use case?
Yeah, so graphs are not a new technology, right? And not a new concept, of course. I think it's the most visual and most native way to actually explain a business universe within organization and connection between different phenomena and different entities, how product is connected to SKU, to branch, to store, and so on and so forth. So different types of connections. 20 years ago, we used to program graphs in MATLAB. Now we have, for quite a while, we already have graph databases, which are great and allow us to actually store graphs in the natural graph formats, like the RDF, which was mentioned on the chat previously, but also feed out schemas as they are, and basically understanding the graph structures out of relational data. So lots of capabilities of graph databases, graph stores, automating many tasks which we are doing manually to convert our data to graph. But thinking about it for a second, big companies usually have lots of different types of data. So it could be financial data, it could be manufacturing, customer data, and so on and so forth. But all of that are stored in flat files, right? Two-dimensional tables. And of course, we have also fact tables to organize all of those connections, but it's a very tedious job to actually handle all of those joins, which eventually end up in loops, right? And then rather just feed up graph database and let all of those connections to be multidimensional and not duplicating any type of data. So right now we in this world of warehouses and databases where data is duplicated many times just because we store it as a flat files, such as table, relational table. In graphs, we save so much space by just storing, for example, product data just once, right? Or sales data just once. Think about Gainsight, Salesforce, we can combine everything together in the same store. So graphs are very helpful to describe the multidimensional nature of universe. And they are used widely for fraud prevention. In COVID, we had many interesting use cases of understanding the root cause analysis of COVID spread, features of the COVID, and so forth. Did it answer the question?
Thank you for that. So back to the semantic layer more generally, how does it fit in a data stack, and especially in an existing one, because most of the companies already have a big data stack of their own? How do you fit that in?
Yes, so I believe because we have multiple data sources, even within organization, and different applications using those data. And nowadays, we more and more understand that external data have even bigger impact to our analysis. And we have initiatives such as industry clouds, which are storing more and more data, external data, of course, public one, for our use as well. So we have lots of fragmented data everywhere, internally, externally, publicly, privately, on-premise, in the cloud, and so on and so forth. So implementing the map and interpretation of data analytics within just one layer, like data layer, for example, for data sources or applications such as BI or some more niche applications for like lead scoring or something like that, will only cover part of your data. So, and this will actually preserve the silo usage of data and silo mapping of data. So I do not see another choice by keeping semantic layers standalone from your data sources, standalone from your ETL tools, and standalone from your applications.
And can you explain why is it better than going straight to the database? Why do we actually need it?
Okay, so yeah, that's a good question. Why do we need semantic layers? Okay, they're standalone, they understand our data in every place, but how do we use them? So what's the purpose of semantic layer? So semantic layers, think about encyclopedia, kind of encyclopedia or inventory of all your data analytics. How many times did you did analysis because you simply cannot find queries that you're sure someone already implemented in some of the systems, but you couldn't find it, right? So the map is a kind of roadmap of all of your existing analysis of all your existing assets stored in one place. I would say goes threefold. So first of all is understanding what you have, such as ingredients in your fridge, gives you ability to think about what are the possible analysis, what are the questions you can ask, right? What are the dishes that you can prepare? So opening up to new possibilities, because if you do not see the ingredients, you cannot know what to ask. Like it takes right now the process of actually going and talking to architects or analysts in different divisions takes so long. So understanding what are the whole comprehensive and relevant data to your question in hand is a very lengthy and an intensive process. So mapping inventory is the first benefit of semantic layer. Second one is actually self-service discovery, right? So if over, say, for decades, I was not there yet, right? So, but for very long, we already talk about self-service. Citizen analysts would like to, as many people as possible, to touch data analytics, either use it or create it, but basically understanding what's on the table, like, for example, which dashboards we have, or so on and so forth. So basically, self-service discovery of all of the assets from a single interface. It doesn't have to be in the semantic layer. It could be from Slack or from your BI tool or what have you. But being able to self-service and understand the context of usage of different assets is something which semantic layers should provide out of the box. And the third one is governance. So I do believe that governance actually belongs to semantic layer. I know that it's kind of Catholic. Some people agree with me, some not. And governance is basically the inherent ability to understand where the conflicts of definitions or duplicate meaning. So for example, if you define a lost customer in different ways in your financial systems and in your sales systems, and that of course get different results in your dashboards. I see you're smiling because you probably saw it in your BI dashboards for once from the financial background. So basically, all of those inconsistencies could be detected by semantic layer, and those detections could be communicated to the users, like by alerting, maybe even possible remediation. So I know it's like different definition of governance. I do believe that this actually defines governance, being able to understand what's conflicted and alert about it, maybe also fix it. 3 value propositions. I know it was a very long monologue right now. Autonomous mapping, mapping your terminology, encyclopedia of business terms and metrics, self-service discovery, and the third one is governance observability. Call it in different ways. Yeah.
Though I really like the governance part, what rang most with me was the self-service, because personally, I find it very hard to trust something that I don't do myself, that I don't see myself. And once I have self-service for the data stack, that I can see where or why the question to answer is, much easier, I think, in my opinion. Let's go back to talking about generative AI and its use in organizations. How do organizations actually use generative AI? You said that some of them banned it, some of them are in the midst of writing policies on how to use it, but how do they use it?
Perfect. I will come to this question just in a second. Mark over the chat asked about if we assume that a graph database should basically contain the whole organizational data, especially for large companies. So I think it's not the solution. So basically, repositioning or like throwing everything in the same bag, like we did with Hadoop 20 years ago, doesn't really help. So I do not think the data should reside in graph databases. The data should be stored where it is right now, right? So it's fine to keep it where it is. It's also fine to combine it with data lake. What has to be on the top is kind of mapping, again, semantic layer. I think the semantic layer should be hosted in graph databases. So graph databases should not be a runtime environment. There should be this translator, right? So basically rerouting requests to the right data repositories, not containing the data, but routing the requests to the right data sets within the organization. Does that answer the question? Okay, so now I will, I will actually address what you asked. So how generative AI is already used in different organizations. So projects what we already saw in organizations, and we work with mostly, I have experience working with organizations in insurance, financial space, also pharma, retail, IoT, and so on and so forth. So majority of the use cases are actually implemented on very narrow use cases. So very well-defined business benefit. Usually the data is not very sensitive right now, and the majority of those experiments are just to taste how you can convert generative AI usage into data products, right? And create a use case, a bigger one out of it. I do not see any enterprise right now already implemented and launched productive use of generative AI service, which is not very well defined. Now, when we say very well defined, how is different from BI and dashboards which we already have? So far, we could sleep at night as data people because we had reports and dashboards and all of those guarded gardens of data consumption, right? And even then, as Anat started this conversation, only 20% of decision making is based on data analytics. Even if you invest so heavily in data quality of dashboards which touch business users, and still they're not making decisions based on this dashboards, we have a huge problem. So I think what happened since Chief Data Officer spread started about 2 years ago is Chief Data Officers were trained, really pressured to launch as many data products as they could. And they did, but all of those data products were very opportunistic, if you will. So, for example, I would like right now to score leads, right, or to attribute campaign costs, and so on and so forth. So very well-defined use cases, siloed. The data underneath was carefully curated. What's we're missing is actually the infrastructure which could scale for many more, right? So in the past 2 years, many data products were launched, right? Most of them in data mesh approach. But what didn't happen is infrastructure which could enable this data product scale to be sustainable. And what we have right now, not only expectation from management to continue and inflate the number of data products internally and externally and monetize them. This is expectations from Chief Data Officer. But now the expectations from managers like CEOs, for example, is to implement the experience which is similar to ChatGPT, but within enterprise. Like ask anything, I can ask anything on even on internal data, right? But we cannot support the scenarios, especially not in enterprises. Data quality is subpar. Our tools do not really provide us flexibility about how we augment data governance. So in simple words, how do we make sure that there are no conflicts of definitions? So for example, someone asked me where it belongs, like where semantic layers belong. If semantic layers belong to BI, they can have specific definition of metric. If they belong to Snowflake, they can have different definition of metrics. There are no mechanisms in organizations right now which could on scale detect different conflicts. So when you ask about how my sales in Germany doing, actually generative AI can go to some table from 5 years ago. It can go to the data which is coming from Salesforce. It can go to financial database, and it will never know. Right, so what we cannot govern in augmented, scalable way, not with people, not necessarily with people, we cannot really bring to wider adoption.
Hi, Vicky.
Yeah. I actually remember governing these Excel files. I actually remember governing these with Excel files. I used to just make sure that the data in all the systems are the same. It's the same.
I think we have someone online.
Someone wants to ask a question?
So let's answer to Mark on the chat for now. So Mark actually proposes two-layer graph solution. One graph is for semantic layer, the second graph for the data itself. It sounds great, but based on my experience and based on experience with companies I'm working with, the amounts of data they have simply cannot perform on any data on any graph database infrastructure. So Tiger Graph, Neo4j, any like relational AI is great. All of them is great, but imagine right now like trillions of columns, and I'm not exaggerating. It's in the manufacturing, chip manufacturing account that I work on. Imagine dozens of databases. You cannot fit all of them in, even if you do multi-instance landscape. It's a huge amount, and none of solution engineers and none of the vendors I mentioned and other ones could really tackle the problem. So having all of this data, it really depends on the size of organization. So if organization is smaller, of course, you can use some kind of a solution for graph database, put all the data in, and maybe separate the semantic layer for the sake of governance and mapping due to applications. But otherwise, it's just, but you're right, joins joins are dangerous, and this is why we need governance segmentation. So it's basically says to you, it tells you where joins went wrong, right? Because of different definitions of logic.
Well, that's of course a dream. Yeah, I know in practical terms. But actually, I wanted to ask something. I was thinking about what you're saying about semantic layer.
Yeah.
And in a sense, what you're doing is replacing, it's like when you have a codified law replacing custom, right? So you have, especially, I worked for a long time for a large financial institution, where there were, tales which were told about databases. And in one particular case, there was and this is where the question I think gets interesting for you. There was one particular database which was considered, because of the tales, there was a convention that it was wrong. It was generating wrong numbers. The process which was created. And it turns out that this was incorrect. That the numbers which were in that were actually correct. And we are talking about very significant loss, which happened afterwards. And of course, I was on the side of internal controls, right? And then you have the conversation, well, you knew that all along, right? Like you had all the data, look at the graph, look at the thing and I see there is a huge opportunity in the sense of how to avoid something like that. So there was an indicator, there was a database, everything was right, except there was the informal or people-based semantic layer which said that was incorrect, until it turned out, oh my god, this is actually true. And we're talking a lot of money, big organizations. So like how this would help solve this?
How to solve it? So unfortunately, some things supposed to be augmented or automated. I'm saying unfortunately because we as humans have hard time to release some tasks. So I think it's the same for urban driving, right? So if all urban cars were automated,
everything was automated. Yeah. That's the beauty of it.
Everything was automated, and still semantic layer was wrong.
There was no, it was correct, but there was a convention. There was a tail, right, which turned out to be completely incorrect. That was actually right.
I understand. So this is why I'm saying that semantic layer is just a schema of graph database is not enough, right? So semantic layer should also have access to the applications where business logic is stored, right? It could be, I don't know, RPA application, it could be business intelligence application, it could be some homegrown application, doesn't really matter. So those applications contain logic. And when we combine logic with the semantic layer, which is coming from data sources, this is where we can find inconsistencies, right? And some of those inconsistency definitions actually get worse because of what I just mentioned. We used to catalog the data by manually describing different definitions and connections between different logic components in Excel and uploading them to older tools, right? So the logic was documented in this way, which was separated from the actual data schemas, from SQLs, which also have all of this logic, from applications. And this is where we have those discrepancies. If you do connect semantic layer to metadata of applications and data sources, you can find like multiple inconsistencies, right? How calculated column is defined, how dashboard is defined, and how alias in a query is defined. So like 3 different points of failure of how you define the logic. When you have all 3 of them, analytics layer, data layer, and application layer in the same place, identifying different entities which have conflicts, which are misused in scenarios like hierarchical metric, for example, hierarchical calculation. This is where you actually find all of those pitfalls automatically, right? I'm not saying it doesn't require man-in-the-loop understanding, like, why did it happen? How we prevent people from maybe implementing new conflicts, right? Misusing different metrics and different definitions in the first place. So I do think that data literacy is a big thing. I think it's a loss to the battle to actually teach everyone what different data sets or data assets could mean and how they can use them. Right now, we're already in the era of prompt engineering, right? So if it's prompt engineering done at ThoughtSpot or some other BI tools and natural language query engines, or those are done via like chatbots and with generative AI, who knows what will happen in the next 2 years. But now we should, right now, implement a mechanism which will govern prompt engineering on all levels, right? Trying to interpret the questions and try to come up with answers which are consistent with organization practice so far.
Thank you.
Do you agree? It's just point of view. It's the whole thing is point of view, of course. Okay. Anat?
Sorry about that. You touched on that, but I want to focus on the role of semantic layer in AI consumption in organizations. Is it simply mapping your databases and systems to the actual meaning of the data, or is there more to this? I mean, you touched on that, and I think that the question now was to the point, but if we could focus on that a bit.
Yes, so basically, exactly as Mark mentioned, questions or analytics within organization could be interpreted in different ways. And this is usually what creates inconsistencies. Having this guard, this man in the middle, which can understand the question, understand it might have not well-defined parts. For example, country of sales is not well-defined in data so far. So it can iterate with the user and ask, okay, so which one did you mean? And so on and so forth. So basically being this man in the middle, understanding the question till it's possible to interpret it in just one exact mapping and basically match the right components is how we can take it further. So first, step 1 is mapping and interpreting all existing assets. Step 2 is supporting the questioning. It's like questioning intelligence, lot IQ, QI, questioning intelligence, and also stitching with the questions, because like, I don't know, when I started to use BI tools many years ago, I actually have the challenge, like, how do we ask? Like, what exactly do you ask? So having this assistant, what should we be asking? Like, what people in my positions asking, what people in the industry asking. So having this kind of questioning intelligence, assistance, and governance and mapping, I think this is the future of semantic layers. I think Gartner touched it widely in this latest report about semantic AI, how it actually brings business value out of data and accelerates data product creation. But actually, big fan of that.
And something that I think we all have in mind is that organizations, and especially large corporations, have many third-party services and internally developed systems and data sources. How does that work into the consumption flow that you've described? I mean, these are a lot of extremely different things that can be even very specific to a specific organization.
Okay, so what we did we do till now? Like we had this external data. So think about you are a retailer. So you have point of sales data, right? You would like to have loyalty, club analytics, and so on and so forth. But you would also like to have some manufacturing data to add to it to have the full cycle and enrich your analysis, right? So far you would buy the data from manufacturer without even knowing what's in it, and then trying to integrate. Usually it would involve like some intern or student for computer science who would go and manually try to match the schemas, right? To basically understand if anything is matching. And with hierarchies and star schemas and the dimension table, like it's a nightmare. Not always exact result that we mean. And so think about this like multiply it, right? So data is going to be published. Think about the US. This US initiative. So US initiative is about all data from government agencies is published in just one marketplace. So weather data, traffic data, security data, all of these things are just accumulated in just one place. But it's up to you to integrate it between each other and with your own organizational data. Again, it used to be hard till now. And now we expect it to run a generative AI on top of it, right? So again, generative AI is not trained on domain-specific data. And of course, it's also not trained on combining different data, which are maybe coming from different domains into one workflow. So again, semantic layers could be very handy on that because if not solving the integration problem, they can actually link you by suggesting which semantic entities look related, look similar. This is where graphs become very handy, even if natural language processing is not good enough to identify connections by, I don't know, synonyms, by correcting spelling mistakes, by using industry abbreviations. Not all of that could be covered by NLQ, especially in enterprise data. We all like those weird names like column 26 or final temp table or INAS files or whatever. So lots of interesting names in organizational data. Joining them, integrating them with third-party data is very, very hard. So this is where semantics and large language models are not enough. This is where we can actually leverage relational models from graphs. And by analyzing the usage context, we can understand which parts are supposed to connect to each other. So basically, we can use semantic layers which leverage both graphs and natural language technologies to bring third-party data and internal organizational data to some common denominator. If not 100%, it solves lots of heavy lifting. Yeah.
Still, there is the data team, and they have BI tools, and they have other manual tools. They should be able to solve the problem because up until now, I think they did pretty okay, I think.
So the question, why do we not actually tackle the integration and questions problems manually? So first of all, I do not think that we excelled so much in that. And excuse me, my colleagues are building like data teams are the most trained teams in organization, right? So they have pressure from both sides, IT and chief security officer, and the CFO is standing like it's like black hole of investment, right? So it's a lot of pressure from all sides, from stakeholders, from managers, from IT, from everywhere. From privacy law. And now we also have this pressure of not only curating specific pipelines, not only curating specific data and specific dashboards and answering questions one at a time, but also like have the same scenarios like on all of the data. In Science, we had the statistics which says that dashboard of medium complexity takes 2 months to implement. It's 2 months to implement one single dashboard. It's like a storyline about specific business questions and some supporting information. 2 months. So someone asks the question and he gets the answer 2 months later. in many of those times, actually the answer doesn't up to his liking, because like his gut feeling or her gut feeling says, okay, it's not like my cells do not look like that. And then we understand, okay, we took a different table, like we shouldn't take like a churn from the sales force, we should take churn from customer success, something like that, because it's different, right? So it was already complicated enough. Right now, we also expected to do the same on many questions and much more data. So this is why, as data professionals, we should actually bless this technology, like both chatbots and data mapping and interpretation technologies, to help us with the heavy lifting. Because I do not think that any of us was born for the tedious task of going and finding the right tables and then matching schemas and so on and so forth. So lots of blessing in this new technology breakthroughs. I think that many of data teams are actually intimidated by this technology, but I do not think there is a big reason for that. We all want to be closer to business, to understand the business better. I think this breakthrough in both LLMs and graphs allows us to understand the business better, to maybe be proactive and actually suggest different data products and business use cases to our stakeholders, instead of being reactive and implementing what we asked for. Yeah.
Okay, that's great. I think I'll ask one last question. Generative AI in organizations and its implementation. Once you clean or map your data, how does the process actually work? Do you need to pull some corporate data and feed the LLM for each query, or is it a different process? How does it work?
Okay, so if you implement internal LLM pipelines, you would train your models on organizational data. Again, there's a huge challenge to actually train models on organizational data, because organizational data are not always semantically meaningful. So I would say that having this, if you already have catalog or metadata activation solution, it's great. It's like first step, even if you do not have like semantic layer. Just use whatever mapping technology you already have, because it will, even manual one, it will help you to prepare your data to implement large language models. If it's internal training or if it's external tool usage, anyway, step one is to preparing your data to be used, right? And it also includes deprecation, right? So based on my experience, lots of companies have deprecated data they're not aware of. And large language models will find it. They will find it, and you will get your 42 answer, right? Without explanation, you will not know where it's coming from. So please do deprecate this kind of data. Again, catalog, semantic layer, what have you, like many of the tools can help you with that. And the rest should have a meaningful naming, and you would not want conflicts of definitions. So there is data zone concept, which says even in the same warehouse, if you would like to use the same terminology, like active customer in different divisions defined in different way, separated with data zone, and then you can basically inherently use this governance for the questioning. So data quality preparation is step 0 for implementing any large language scenario, internally, externally. And then, as I mentioned, the governance and interpretation and assistance of the inputs of the prompt engineering, it will give you transparency about how your question been understood by the machine. It will give you more accuracy, because LLMs will get a much more focused and precise part of your organizational schema, right? It will not go wild on all enterprise data and so on. So it will get context, right? Many of the context. And then you can ask many questions, because otherwise you will have to validate each answer. And how to validate each answer? You basically implement the query. So, yeah. Why not to do a RAG for internal data? I'm not sure what RAG is.
Retrieval augmented generation.
Okay, can you explain what do you mean? Because I'm not sure how it it helps previous question. Maybe I'm missing, probably missing the context.
Basically embed the parts of the data, and instead of training the LLM from start on your data, just give some of the important data for the question in the prompt. In context learning, not full learning that is expensive for LLM.
This is true. So basically what Lior is saying is just passes as a context. So context right now is limited in the most advanced LLMs, to my best knowledge, to around, think about like 50 pages book, right? So this is maximum context that you can right now give to LLMs.
Lot 2 is 100,000 tokens, and
yes,
ChatGPT is 32,000 tokens.
That's true. When you think about this number of tokens, it's more or less like 50 pages book, because every page has so many words in it. So
plus minus 20,000 words, let's say.
Yes.
10 to 20,000 depending on how big your LLM is.
This is true. What is the length of your average query? You understand where I'm going with it?
Yeah.
Okay, so to your question, you can do it for, you're right, for specific, like critical, you have a specific data set and one application on top of it. For relatively small amounts of questions or small amounts of data, it's totally doable. So basically, this is what vector databases are doing. You can embed in transformers limited amount of data, like documents, for example, and then ask questions on top of it. But now scale it to the whole data. Again, it's very, very, very complex. Much more complex than to make sure that all data assets are well documented, like physically, right? I'm not saying it's not valid approach. So if you have table for your annual reports, you can totally do it just on one table on specific number of metrics.
Okay.
But I know that we're on top of the hour, and Verit is probably going to kick us out in a second. So all of you who would like to have like follow-up discussion and, friendly coffee or just a Zoom conversation, connect to us. We can have those. The idea here was to really expose and have this creative juices of this community, speak about graphs and large language models in the context of data management, data mapping. I hope the goal was achieved. If not, you're welcome to have follow-up sessions on that, and I will be happy to participate and ask questions. Thank you so much, everyone.
Thank you, Ina, and thank you everyone who listened this evening. Have a lovely day.